Hello everyone, welcome to ExamPreptool DSA 30-day challenge. Challenge number 22 answer I am giving. Let me read the challenge number 22 once again before going to the answer. One array is given. In that array, find a subarray of size k whose sum is maximum. Suppose assume that k is equal to 2. Suppose assume k is equal to 2. Subarray of size 2 you have to take. This is the subarray of size 2. This is also subarray of size 2. This is also subarray of size 2, right? So find out all subarrays of size 2, right? Add them, whoever is the maximum sum you have to take. I think maximum sum is this one, right? Next one, k is equal to 4, so array of, right, subarray of size 4 you take. Subarray of size 4 you have to take. Subarray of size 4 you have to take. Subarray of size 4 you have to take. So maximum sum, you calculate properly, 39 will come. From this problem, I want to explain one of the extraordinary logic to solve most of the problems. With the help of this problem, I will explain. First, I will explain with the help of program. Lastly, I will explain the logic, what is going on. Right? Let's go to the program. Right? Program is not important, logic only important. First, let me complete. I written the program. Let me explain properly. Then lastly, we will see the logic, what is going on. Using that logic, most of the problems you can solve. Right? Let's see here. There is one array, see this one. From main program will start. Right? Program is not important. Logic is important. Lastly, I will say what is that logic. Right? See this one. So one array I took, which contain I think 9 people. So I find out size, k value 4, everything is fine. Now see this one. Array which contain 9 elements. I want to find out a subarray of size 4. I want to find out a subarray of size 4 whose sum is maximum. That is our goal. So 9 came here, 4 came here. Right? Now see what I done is I took two variables, I and j. I took two variables, I and j. Right? Both are pointing. Let me give indexes also. 0, 1, 2, 3, 4, 5, 6, 7, 8. Right? I also pointing to first index. J also pointing to first index. Remember. Ij pointing to first index. 0th index. They both are pointing. And one more thing is remember everyone. Current sum is equal to 0. Current sum. Final sum. Final answer is this one. Final sum is 0. Right? Listen the program first. Lastly, you will get the one nice logic. Using that, you can solve most of the problems. Right? This is the current status. Current sum is this. Final sum is this. Final sum is this. Remember, current sum means it will always change. Frequently changed sum is current sum. Final sum is whoever is the better person. If I find out better, then only I will change it. And remember, I want a subset. I want a subarray of size 4. Subarray. It is not a subsequence. It is a subarray. Subarray means continuously how to take. Subsequence means you can take random places also. Right? Fine. Subarray of size 4 I want. And one more thing, remember, I to j elements are there. I to j elements. If you want to find out total elements, last element index minus first element index plus 1, you will find out the total elements. You will find out the total elements, right? Remember that formula. So let's start the story. I, j both are pointing to same index. Remember, j is the one which will increment most of the time. I will increment very rarely. You will see now. You will see what is happening. You will see what is happening. J will always increment. See, J will increment here. Only two cases are there. J will increment here also. J will increment here also. I will increment only for else part. Right? So let's quickly go inside the code. Let's start one by one. As soon as you started, sum will add first element. Sum contain first. So sum is already 0. 0 plus first value. So it will become 1. Sum became 1. Sum became 1. Next one, immediately check how many elements you taken till now. I also 0, j also 0, 0 minus 0 plus 1. 1 person only I taken. 1 less than 4 condition is true. Condition true, j plus plus. J value became now 2. Sorry, previously 0, now it became 1. J value become 1. And one more thing, because of if condition true, else will not. else will not. So I think what is the answer? It is going on within the loop. This is the loop, right? If condition, right? If condition I executed true, else will not execute. It will go as usual. So else, I think if you see the else story, let me check here. Where is the else clause? Else, right? Else if this condition, this will close here. This will close here, right? This is the main bracket. This is the main bracket. I think this one here close. This one and this one. This is the closing of this. This is the while clause. Assume it is a while clause. This is the else clause. This is the else clause. Right? This is because if contain only one statement, if contain only one statement, you no need to bother. Right? Else contain many statements. Else contain many statement. Bracket required. This is the while. Right? Now start. Now start. Everything is fine. So first time I checked, I and j both are 0. Condition is condition true. J plus plus. J value becomes 1. Right? If condition true, else will not execute. Else will not execute. Then go back. Right? Go back to loop once again. Now see, sum is equal to sum plus a of j. So j became here. So this also added to the next sum. So what is the answer? Already sum contain 1. 1 plus 4 became 5. Sum will become 5 now. Right? After this sum is over, next one, once again check ij. I is 0, j is 1. So I think 1 minus 0 plus 1, 2. Right? 2. Right? 2 less than 4 condition is true. Again j plus plus. Again this condition true. So 0 less than 4 condition true. 1 less than 4 condition also true. Again j plus plus. J will increment by 1. J value becomes 2. If executed means else will not execute. Right? Now once again go back. Once again go back. Again sum will update. So sum is equal to sum plus a of j. So j will be here. J will be here. So I think sum contain 2 more will be added. It became 7. It became 7. Now immediately after sum is over, again check how many people. I think I value 0, j value 2. Right? 2 minus 0 plus 1, 3 people. So previously 1, now I think it is a 2. 2 less than, right? 2 less than 4, condition true. Right? 2 less than, right? So this condition true. J value is 2. Right? Afterwards you done the sum also. 2 also added. Right? 4 plus, right? 5 plus 2, 7 it is done already. Next one, right? 2 minus I plus 1, I think 3. 3 less than 4. 3 less than 4. This condition, let's see. 3 less than 4. This condition I am talking. I think it will start from 1, right? Yeah. Initially 1 element. 1 less than 4, 2 less than 4, now 3 less than 4. Again, condition true. J plus plus. J value becomes 3. J value becomes 3. Now, as usual, check once. Right? So, this here also check. 3 less than, right? 3 less than n here. It is n is 9. Here n is 9. Please get it. 3 less than 9, condition true, come inside. Sum is equal to sum plus a of 5. I think j will be here. J value 3 now. J will be here. Add it. It became 17. Now j value 3, remember? So, right? So 3 minus 0 plus 1, 4. 4 less than 4, condition fail. What indirectly, directly, what is happening is, I want to find a subset of k people. Subarray of k people I have to find out. Now you find out. 4 people, sum also available. See this one. 4 people, sum also available, 17. See this. 4 people, sum also available, which is 17. And 4 people you got also, right? This condition failed means 4 people you got, 4 people sum also available. Now this condition failed because you got 4 people. See, 4 people not came until 4 people will come. Please accommodate the people. First person came, second person came, third person came until 4 people. Please make one subarray first. One subarray, find out first 4 people. Okay, I completed. Now I got the 4 people. Now this is the correct time, right? You go to the actual story, right? Let's see what is the actual story. So 4 less than 4 condition is failed. Come here. Is it 4 equal to 4? Means you got the subarray of k people? Yes, yes. Now this is the thing which I am looking for. See what you will do. So current sum and final sum, compare both. Final sum is as of now 0. Current sum is as of now 17. So update the final sum. Final sum became now comparing 0, 17 better. Take. Now see the first 4 people I took. Their sum also I stored in the final sum. From now onwards, remember this is the game from now onwards. Now onwards, what happened is let me change the color. Now onwards, what will happen? I will also increment. J will also increment. Means what are the meaning? Next 4. This is the first 4. Next 4 will come. See the next 4. This is the next 4. I also will increment by 1. J also will increment by 1. I also will increment by 1. J also will increment by 1. But the important thing what you have to do is, right, because of I is incremental, this element will be thrown out. This element will be thrown out because one new person is coming, one old person is going. I moving means old person will go. J moving means new person is coming. Every time one new person coming, one old person is going. See what happened. Whenever 4 people already you got, update the sum first, then what you do is from that sum, remove the first person. From that one, remove the first person. Wherever I is there, first person. Remove the first person, it became 17 minus 1, it became 16. Remove the first person, then I also increment, J also incremented. I will go here, J will go here. Again, do the same story in the while loop. Start now. Start now. I incremented, J value now 4. 4 less than 9 condition true, that's fine. Sum is equal to sum plus A of I. New person add. So to the 16 new person, it became 19. Then immediately check. Is it K people? Of course. Because one person gone, one person came. So is it less than K? No. Is it K people? Yes. Again same. So update the new sum because one more 4 people sum is 19. Previous 4 people sum is 17. Now new 4 people sum is 19. Whoever better keep in the answer, final answer. Whoever better keep in the final answer. Again same story. What is the answer? First person delete. First person delete. Next person add. So what is the answer? From this one, from the existing 19, second person I remove. It became now 19 minus 4, which became 15. Then I will increment, J will increment. I will goes to here. J will goes to here. Every time one old person will go, one new person is coming. Continue until J crosses because J is going in the forward direction. So the first story is one. Arrange first K people. Until K people will come, I will not increment. J only will increment. Whenever K people came, then store this data, store this value in the final sum. From now onwards, I will increment by 1, J will see 1 will be added, 1 will be subtracted. Again, this is the K. Again update. Again, 1 will be added, 1 will be subtracted. This is called a sliding window. Means window is sliding. One position left also, right? Left also will increment, one position right also will increment. Every 4 you will take care. See, first what happened? 0 to 3 you take it. Next, if you slide one position right, it became 1 to 4 you will take care. Next, if you slide the window further, 2 to 5 you take care. Next one, 3 to 6 you take care, and so on. Continue. Lastly, if you see, I think last element is 8th index, na? So 4 people. What is the answer? 5 to 8. 5 to 8. Last one is 5 to 8. Right? 5 to 8, how many? 8 minus 5 plus 1, 4 people. Next one, if you go, J, right? I value also will increase, J value also. I value became 6, J value became 9, which is 9 less than 9. Condition is failed. You will come out. At that time, whoever is there in the final one, that will be the answer. So what I want to say is, let me use another color. Until K people will come, please manage first. Until K people will come, first K people manage this. Afterwards, this is called sliding window concept will come. Window is sliding, right? One position, right always. Right? Left person also by 1 means I will increment by 1, J also will increment by 1. So that window is sliding. See, for initial window is like this. Next window is like this. Next window is like this. It is keep on sliding. Normally sliding window protocol normally will be there. In computer network, people will think that sliding window is computer network. Of course, exactly same. Same, but we are using to solve most of the problem of this kind of behavior. So one scan is going on. See, J going from left to right. J going from left to right. But remember, until K people, I will not increment. After K people came, I will increment, J also will increment. Like that, you will keep on going. So, first 4 people, if you see 1, 4, 2, 10, right? 2, 10. How much it became? 10 plus 4, 14, 14 plus 3, 17. So, next 4 you see. I think next 4, if you see 1 is going, 2 is coming. So, you take. So, find out whatever answer will come. So, one scan only, time complexity, order of n. One scan. Simply one while loop. Simply one while loop. Now let me give the, if you want final answer also, I will give. If you want, I will give final answer also. Let's see one small line. What are the first 4 answer? Current, right? So current sum is first 4. I think 70. So final sum, initially 0. So update with the 70. Next 4 you see, next 4. These are the next 4. Right? 4, 2, 6, 10, 18. Check once. 5 plus 2, 7 plus 10, 17 first. Next one, what happened is 4 plus 2, 6, 16, 16 and 2, 18. 18 better, right? 6 plus 2, 8, 8 plus 10, so 18 better. So it's the 18, right? So it will have, it's the 18, so it will update here also. Next, increase further. Increase further. One more position, increase. 2, 10, 12, 12 plus 2, 14, 14 plus 3, 17, so not required. Increment further. Increment further. 10 plus 2, 12, 30, sorry, 15 plus 1, 16, not required. Increment further, not required. Increment further. 20 plus 3, 23 plus 1, 24. So finally 24. Like this, window is keep on sliding. It is one excellent problem, right? One of the excellent problem. Using these many problems you can solve. This is one of the example for sliding window. You can say, one more way you can say, 2 pointer. We are using 2 pointers. 2 pointer also. Yeah. So time complexity to solve this problem is order of n. So let me write now. Time complexity to solve this problem is order of n. Right? Using this problem, many problems you can solve. Same approach, many you can solve. I hope you got it. I hope you got it. Thank you so much. Right? Thank you so much. See you in the next challenge.